Hello everybody! So this is the first video I've ever made for this project. Figured I'd show you some brief things I learned about solar cells because this isn't really gathered anywhere that's in an easy, short, capable of understanding kind of thing. So I have on the table here a couple different types of solar cells. We have our first one. This is what you'll see in a lot of residential installations. This is called a 5BB or 5 bus bar solar cell. It is 156 millimeter by 156 millimeter. No, I will not be converting that to imperial because let's be real, should we be using anything that has the word imperial in it? Come on guys, 2021. So on the front, this is the negative. The front of a solar cell is almost always the negative. Then on the back, you will see the positive connections. So what ends up happening in order to connect this, you have to take these tabbing wires, what they're called. It's copper coated in solder. I believe it's copper, might be nickel, I can't remember. But you solder to the front, which is the negative, and then to the back, you put positive connections. This one is currently soldered so that this bus bar here, which is what this big thick piece is called a bus bar. That would be the negative terminal. And then you could wire this to another cell in parallel, and you basically go negative, positive, negative, positive, negative, positive, all the way down. And then that gives you a huge string in parallel. I'll show you what that looks like. This is one of the first cells that I made. So this is 6P, basically. It's 6 cells in parallel. You'll see the bottom one is broken. But what the cool thing about solar cells is that this doesn't really matter. You lose a little bit of efficiency and power generation, but it will still generate power. So like if you break one, it's not the end of the world. I will usually discard them if it's really bad, but this one I might try to still reuse, even though it's a little messed up. But this is basically how one connected all in parallel would look like. And you can see that it's all connected on the back. These cells are really cool because unlike the other one, you saw that it had little connections on the back for the positive. The entire back of this cell is the positive connection. So you can really connect them anywhere, but I like to just connect them on the edges because it makes it easy. Now, one thing that's important to note, you'll see, like as I said, I cracked one of them. These are, let's put this down here, extremely fragile. Let me grab one of the ones from that string. So you'll see, super duper thin, extremely fragile, so you have to be very careful when using these because they will crack so quickly. These are a little bit harder to find. They're more professional grade, like more for industrial and like commercial products. These ones are a lot easier to find. I got these from AliExpress, extremely cheap. Oh, well look at that, I just broke one. So yeah, as I said, extremely fragile, but I can still use it, it's okay. So let me try and pull off another one without breaking it. Let's see, come on. All right, here we go. Here's a solar cell. This I got from AliExpress. It is a polycrystalline, which you can tell, you see, I don't know if the camera's capturing it, but you can kind of see multiple little bits of silicon in there. Polycrystalline means it's made up of, it's like a composite basically. These are extremely cheap. They output a decent amount of power. I think these are 0.6 watts if I remember correctly. And it's very similar to the 5 bus bar one, this big one down here that we went over yesterday. 2 positive connections and then the negative connections on the front. But you can't just solder anywhere like on these ones. You have to solder to these terminals for a positive connection. The other type that I have here is these. You can get these. These are for like garden lights, solar garden lights. And then what's cool about these is you can connect them together in these ones here. These are in parallel, and then we have a series connection down here. So this outputs about 6 volts, I believe, because each of these is 2 volts. So it outputs roughly 3 watts of power, roughly. It's a little big, but it's actually not that big. It doesn't output a huge amount of power, but it's enough to charge a phone, just not very quickly. These are a little bit much more expensive because it comes like already encapsulated and everything, but they're still good. Then we have what's called the encapsulation film. So you can just use a cell, whoops, you can just use a cell just like this. Totally fine, but very fragile. You know, as you saw, it will break. Not exactly waterproof, but you know, it will hold up a little bit. You want to use something like this. This is called encapsulation film. Basically, it's a thermoplastic that has glue on the front and back of it. So when you use something like a hot air station, which is, I super recommend getting one of these if you think about doing this, you cut this down to the size of your string, put it on the front and back, and then use the hot air station to encapsulate your panel. And it works really nice. And then for the back of it, you'll want to use something like this. This I also got from AliExpress. They called it Tedlar, which it might be Tedlar and is very expensive, but Tedlar is a 3M product. So I have no way to tell if that's actually Tedlar, but it's close enough. Basically, it provides electrical and weather insulation for your panel to protect it from the elements. So it's a very important thing to have, because if you're going to be having this outside, you want to make sure it's protected. In general, though, if this is just going to be something you like take to the beach or with you, I would still recommend Tedlar. Like, this stuff is really good. It's like super thick. It's waterproof, obviously. I put Coroplast, which is this stuff. It's the same type of stuff that you use for yard signs. This is a little bit more of thicker stock. I would recommend thicker stock. You see, it doesn't really, it flexes a little bit, but not too much. I'd recommend something like this if you want something a little bit more durable. So what I would do is I would take this. I would use 3M VHB tape, very high bonding. I would put several strips down here, and then I would put the Tedlar against this, make sure it's nice and flat and smooth. Then I would apply super glue on this, and I would take one of the pieces of backing film or encapsulation film, put it on top of this, lay down the solar cells like so, and then just put down another layer of the encapsulation film. Make sure your first layer of encapsulation film is nice and flat, and then firmly adhere to the super glue, and then put the cells and then the next layer on top. And then I take, where is it? This basically is Kapton tape. I tape down the sides with Kapton tape to make sure it's not going to go anywhere when I use my hot air station. And then that will get you a nice kind of even encapsulation that looks like, you know, semi-decent. But yeah, a little longer than I wanted, but that's a brief rundown of how you make a solar panel. I may upload more of these in the future. Thanks!